All right, here we go. Algebra 51. All right, so today we're going to graph linear equations and horizontal and vertical lines. A first-degree polynomial equation. First-degree polynomial equations are called linear equations. And linear equations can come in these forms, so I'll write them down for you. As long as they are, well, I'll attempt to write them down for you if I keep the pen up. How about that? First degree, here's one. It's a first degree equation, right? There's only 1 degree there. The biggest one is 1 degree. Okay, these are just 3 examples. There's certainly more than these, but here's 3 examples. And when we do these, we're going to be breaking these down into some things that will be helpful to us. Now, today you're not going to have to figure out how to get y by itself, but you already know how to do that. You already know how to do that because what you've been doing when you've had to isolate y, solve for y on those equations, is they become useful when you're doing these kinds of equations. We're not going to put them both together today. You're going to see some things to help you identify that information. But today, let's graph some stuff. Y equals 2x minus 1. We're going to graph this. Now, there's 2 ways you can graph it, and I'm only showing you one way today. In the future, we're going to do another way that you'll know, but we want to know the basic foundational way first before we attempt a different way to solve this. So y equals 2x minus 1. And the way we can do these, the way we can graph these, is to make a super easy, handy-dandy chart. Okay? So let's make a chart. Real easy. We'll do it right here. We'll call the first one x, the second one y. Okay, I didn't leave myself much room there. All right. And we're going to come up with a bunch of values for x. So let's start making something up. So we'll start with 0. We'll say 2. We'll say negative 2. We can certainly do more. Well, let's start with those 3. If x equals 0, what is y on that equation?
0.
If x equals 0, right here, if x equals 0,
Negative
y would be negative 1. If x is 2, what is y?
3.
If x is negative 2, okay? I have 3 coordinates marked out. All right, I have 3 coordinates marked out. We can go further. I can say if x is 3, what is y?
5.
Okay? If I said x is negative 3, what would y be?
Negative 7.
Negative 7. All right, that gives me more than enough information I would need to graph it. I have all these plot points. I have 0, 1. I have 2, 3. I have negative 2, negative 5, negative 1, thank you. I have 3, 5, and I have negative 3, negative 7. I have all those, right? Graph them out. 0, negative 1. I have 2, 3, 2, 3. I have negative 2, negative 5, way down here. I have 3, 5, 3, way up here. And I have negative 3, negative 7, so way down here. Okay? And then I can connect them into a line. All right? I graph my points. Okay? It's a graph of a mathematical line, and it indicates where my line is in my question. So these can be useful. This is infinite in length. Straight lines in mathematics, this is infinite in length. And we've only graphed a segment. Right? We're not graphing this forever. How much graph paper do you have? It has no width, even though it looks like it has some width. The mathematical line has no width, but we have to see it, so that's why it has width. So this is a graph of a mathematical line, because in essence, a mathematical line has no width, but we have to see it, so there we go. All right, So let's try a different one. Let me clear the screen. Well, what about a new equation, y equals negative 1/2 x plus 2. All right, so we would begin by creating a chart for x and y, and give me 3 numbers that x could be. Just give me 3.
4.
Do the easy ones first. Do 0.
0.
And do something we can cancel because we're multiplying by negative 1/2. What about 2?
2.
Because that's 2 over 1, right? Always pick easy. I know I said pick whatever, but I'm just also trying to tell you, pick easy. What's the opposite of 2? Pick that one too. You can certainly do 4. I'm just saying pick the easy ones, right? Pick the easy ones. All right, so if x equals 0, what is y?
2.
Okay. If x equals 2, what is y?
3.
No.
Negative 3. Wait, no.
If you're not sure, do it. Negative 1/2
Would be 1.
times 2 over 1 equals negative 1 plus 2.
1.
So 1. I thought someone said a different number. If it's negative 2, what is it?
3.
It's 3. Okay, I got 3 points. Now we can graph it. Okay, 0, 2. 2, 1. And negative
Negative 2, 2.
negative 2. Sorry, up here, sorry. And it's a line that goes this way. It's descending. A descending line is a negative line. How do I know my line's negative? Well, I started out with it negative up here. Lines always start on the left-hand side. If they go down, they're negative. If they go up, they're positive. Does it make sense?
This one's negative.
This one's negative.
Was the first one positive then?
The first one was positive because it was going up, starting at the bottom and went up. So yes. All right, so let's do another one. You always forget I can just do that. Y equals negative x. Okay? What could x be? Use this one, you can pick whatever you want.
0.
Okay, if x is 0, y is 0. Not a trick question. This looks easy. If x is
1.
I heard 1,
Negative.
y is negative 1. If x is 2, I'm out of room, because that was the next one I heard, y is, okay, so you can graph it.
It's going to be the opposite every time.
0, 0.
0, 0, 1, negative 1, and 2, negative 2. And it goes down. Because, and you know it goes down because it started off with negative. Negative x, so it's going to go down.
Wait, I don't get that.
If the x is negative, it's going down every single time. Okay? If this is positive, it's going to go up every single time.
What if it doesn't make a line?
What if it doesn't make a line? Huh?
Well, that was
How
They
can it
will
happen?
all make a line. They will all make a line.
You do it right.
If they're not making a line, you did something wrong. Okay, I'll tell you that much. If you start making a staircase, you messed up somewhere. All right? Does that make sense? All right. Now, there are times when we don't. Now, in all 3 of those that we graphed, what 2 variables did we have each and every time? What 2 variables do I have?
X and Y.
X and Y. I have 2 variables, and they're always X and Y. There are times when you have to graph stuff that does not have a variable. It only has 1 variable, I should say. So here's the next one. Let's graph x equals negative 2. All right. This one is telling me that x is always going to be negative 2. No matter what I do, x is always going to be negative 2. So where's negative 2 on the x line?
Just going to go straight up and down. Right?
It's a straight up and down line. Because this tells me no matter what, x is negative 2. Y could be anything, but x is negative 2. That means it makes a vertical line. Does that make sense? It makes a vertical line exactly where it says it would make. Okay, now the same thing applies when we only know y. If y equals 4, our dot is on 4,
It's gonna be 4.
and y always has to be 4 then. So what kind of line does that make?
Horizontal.
Makes a horizontal line, because y always has to be 4. Okay, x could be anything we want it to be, but y always has to be 4, so that makes a horizontal line. So another way to remember the lines they make are always going to be the opposite of what they are. Opposite, x is a horizontal thing on a grid, but when you know x, it's a vertical line. It's the opposite. All right, so finally, let's graph two things on one sheet, and that's our last thing. Two things on one sheet. Y equals 2x is our first thing I want to graph. So that one we're going to need to figure out, because I have two variables. So x and y. Give me what x could be, somebody.
0.
Okay, always start with 0, why not? If x equals 0, y is?
0.
All right, so that's where we'll start.
2 and
2. If x equals 2, what is y?
4.
4. So that's 2, 4. And notice it's positive, so we're going up. All right, so give me one more.
3.
X equals 3, y equals?
6.
3 is usually good enough, but sometimes you need more. So you see your line is going that way, right?
You have 2 cubes, 2 4.
What?
On the side.
On the graph on the side. Right there.
Oh, I wrote 2, but I graphed 4. That's funny. Thank you for correcting me. I wrote 2, but I graphed 4. Okay, and now graph y equals 2.
So y always has to be on 2.
Y always has to be 2.
So the answer is 1, 2.
So if I want to know my point of intersection, my point of intersection is 1, 2. Yes. Any questions on that? Not too hard, is it? Now this is just like a basic thing. This is going to come into play with harder stuff later, but you've already started on the harder stuff 10 lessons ago when you were told to, way back when you had, let's see, this equation, y minus 2x, remember this one, y minus 2x plus 1 equals 0? Remember, do you remember doing these?
Yeah.
Solve for y,
Yep.
that's y equals 2x minus 1. You could graph that, couldn't you?
Mm-hmm.
That's what you're going to be doing. You're not doing it today. That's what you're going to be doing. That's something you've done for a while. This is something we just did. You're going to put them together on the one. Okay? Does that make sense? We just built two principles, two pieces of foundation, and we're going to build on top of that. All right? So I'm just showing you something that you've been doing for a little bit that you think is pointless has a reason. And it's going to be with the graphing stuff. When you figure out slope of the line and do it mathematically. Okay? So there's a definite reason for doing that. So, didn't do it because I didn't press stop. Still didn't press stop. Stop, stop. Just like, I give up.
What does it do if it's back or on?
Get away.